Hi, we are from Group 3 and we will present about Lab 4, which is the milling process. So here's our team members. The first one is me, Edmilia Tan. Next is Usama, and Nakib Danish, Putra Shahmi, Amni Marina, and Muhammad Hafiz. So the thing that we will present is, the first one is the introduction, tools and equipment, process plan, methodology, result, discussion, and conclusion.
First, we go for the introduction. Milling is a machine process which is material removal process. In this process, it creates variety of features on the part of the cutting away the unwanted material. The main objective of this course is to expose the student to the milling operation and train them to use the milling machine. Consistently straining and deepening their understanding of the principle of the milling process.
So in milling lab, we should use a milling machine. So what is actually a milling machine? Milling machine is actually a manufacturing tools that used to remove material from the workpiece just to achieve the perfect shape and size. So this is the picture shows the milling machine. This milling machine could undergo process such as face milling, peripheral milling, and also the end mill milling. So this machine speed could control and adjustable just by using this formula, n is equal to v times 1000 over pi d. So this milling machine could help in this operation, which is the first one is facing. Facing is to obtain smooth and shiny surface from the workpiece. And the next one is the milling, which is to shape the workpiece. Drilling is to make hole from the workpiece, and chamfering is to remove sharp edges after all finishing process. So what are the tools and equipment that we will use? The first one is the center drill. Center drill is to mark the starting point on the workpiece to ensure that the hole that we want to mark is perfectly there. And the next one is the C-type wrench spanner, which is to tighten and loosen the drill bit from the drill holder. And the third one is the counter bore, just to create a flat bottom cylindrical recess on the workpiece. It's just like hole and is flattened inside it. And the last one is chamfer. It used to remove the sharp edges from the workpiece. We will also use the end mill holder is to secure the end mill cutter inside the milling machine. And the next one is the collet. Collet is used just to hold the small diameter thin wall shape point under the milling machine so that it is perfectly secured. And the next one is the end mill cutter. In this lab, we will use the two fluid end mill cutter, which is just to remove the materials and shape the workpiece. And the last one is the drill bit, just to make a hole with a specific diameter. We will use vernier caliper to measure the length, width of the workpiece, and just to mark what is the exact measurement from the workpiece. The next one is the angle plate. We'll use this angle plate while using the vernier height gauge just to provide a stable base for the workpiece. And the next one is the vernier height gauge. Vernier height gauge is used to mark the vertical measurement for the workpiece. And the last one is the hammer, just to tighten up the workpiece on the milling table, because we need hammer just to make sure that it is securely locked on the milling table.
Assalamualaikum and hi, my name is Usama bin Ilyas. My metric number is MA23110. And today I will talk about our process plan. So for step 1, we use a vernier caliper to measure each side of the workpiece to determine the length needed for facing and milling process. Then turn on the milling machine on. The control panel is placed in front of the machine and within reachable distance from the student. Step 4, choose suitable fluid, and we use 2 fluid and mill and insert it into a chuck and collet at half part of the body rotation. And then the workpiece is secure on the milling machine by using the vise. The Z-axis, X-axis and Y-axis handles are moved until the surface of the workpiece reach the end mill. For the step 7, next, the x-axis must remain static to make sure that there is no any error during the facing and milling process. After that, make sure that the tire indicator is set to 0 before start any process. During the facing process, the x-axis and y-axis handles is moved until the end of tool to obtain a flat and shiny surface from the workpiece. For step 10, the surface is cleaned with a brush after every process. After facing, the workpiece needs to be measured by using a vernier caliper to make sure that the measurement obtained is correct. Use a vernier height gauge to determine the measurement of each part of the workpiece. Repeat step 4 to 8 for the slot machine section. During the slot milling section, the cutting tool at the middle of the workpiece must be controlled by using the x-axis handle while the z-axis is lowered by 2 mm. And then, use a vernier caliper to measure the workpiece every time the milling process. Next, repeat step 13 to 15 for the other components by following the measurement required. Change the 8 mm drill bit and place it into the milling machine. Start the drilling process until a hole is successfully created. Repeat the same step, that is step 17 and 18 for the 9 mm drill bit. Change the drill bit to a counterbore drill to make a large long hole at the upper part of the workpiece. Students are required to refer to the lab manual for the measurement required. Repeat step 13-15 to complete the process. Turn off the milling machine and use a brush to clean it. And lastly, use a chamfering tool to chamfer each hole, as this process could remove the sharp edge and prevent from any injuries. That's all from me. Thank you.
Assalamualaikum and hi. My name is Amni Marina, student ID MA20157, and for my part, I will presenting the summary of methodology for this project. First up is the facing process. In the facing process, the initial length, width, and height were measured using vernier caliper. Then, two sides of the workpiece were milled to be set up as a datum surface which acts as a reference. The workpiece was measured and marked with lines based on the required dimension according to the work drawing plan using vernier height gauge. All of the surfaces were milled according to the marks with a face milling cutter. Then, all of the edges on the workpiece were filed with a flat file to remove the sharp edges and steel chips after all of the work was done. Next is the milling process. In the milling process, the parts for step milling and slot were marked with a vernier height gauge. The selected end mill cutter was installed to the milling machine. Note that safety goggles must be worn during the process. The step milling with a depth of 4 mm was done on the workpiece using end mill cutter size 16 mm. The slot was made by milling a depth of 1 mm using end mill cutter size 8 mm. The workpiece was cleaned and smoothed from steel chips afterwards. Lastly is the drilling process. In the drilling process, the points for drilling were marked on the surface with a vernier height gauge and center punch. The center drill was used to initially drill the marks. The points were then drilled to make holes using drill bit size 8 mm for one hole and 9 mm for the other hole. One of the hole, which is the hole size 9 mm, was drilled a counterbore hole with a depth of 5 mm using counterbore cutter. The workpiece was regularly brushed during the process to remove steel chips from the surface. Finally, the sharp edges were chamfered manually with a deburring tool after all of the work was done. For the next part, I will pass on to the next presenter. Thank you.
Assalamualaikum and good morning. My name is Muhammad Hafiz bin Muhammad Sukri and I will present the discussion of the lab. To begin with, the lab assistants provided a comprehensive introduction, demystifying the tools essential for mining, from drill chucks to deburring tools. We grasped their function, setting the stage for efficient operation. We then delved into the mining machine and standard operating procedure, empowering us to organize our approach systematically. What set this lab apart was the invaluable hands-on experience. Each group actively engaged with mining machine and tools, translating theoretical knowledge into practical proficiency. This real-world application not only enhanced our understanding but also honed our problem-solving skill. However, no journey is without hurdles. Our encounter with a dimensional accuracy issue was an unexpected obstacle. The mile dimension did not align with our expectation due to a calibration error in the mining machine. This posed a challenge to our efficiency and reliability. Despite the challenge, the lab enriched our knowledge of mining principles. We became adept at understanding mining operation, translating drawings into tangible results. Additionally, the importance of safety precaution became evident. Wearing a safety glasses, shoes, gloves protected us from potential hazards. Regular checks on machine functionality and proper clamping of workpiece ensure a secure working environment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nakib and my ID number is MA23099. So today I will talk about the conclusion of our experiment, and our experiment focused on three things. And the first one is organizing and operating mining machines, and the second one is emphasizing the importance of cutter selection, and the last one is avoiding interference and ensuring tool sharpness. So what did student learn? Student learns three things. That are students learn to calculate stable feed and RPM. The second one is enhancing skills and confidence during facing, miling, and drilling process. And the last one is safety consciousness, including proper attire and precautions, was emphasized to prevent accidents. And last but not least, we want to express our gratitude to the instructors because they provide clear explanation and emphasizing the significance of approved safety equipment for eye protection. And that's all. Thank you. This is our reference for lab 4. There is some pictures of what we do during our lab session.